Welcome to the online training, module number 4, lesson 7. Lesson 7 will look at regression discontinuity design. In this lesson, we'll cover several subtopics, but first we'll look at an introduction to regression discontinuity method. Then we'll have a discussion on regression discontinuity method. Then we'll also look at regression discontinuity in theories, like the notations, and then application of the regression discontinuity approach. And finally, conclude the lesson discussion with advantages or concerns of regression discontinuity approach. Introduction. In an experimental setting, program eligibility rules can sometimes or oftentimes be taken or used as instruments for identifying participants and non-participants. So the rules play a key role to distinguish between who is eligible to participate in a program and who is not eligible to participate in the program. Now, to establish comparability, one can use participants and non-participants within a certain neighborhood of the eligibility threshold or cutoff point as the relevant sample for estimating the treatment impact. So regression discontinuity methods or method allows observed as well as unobserved heterogeneity to be accounted for. So both observed and unobserved characteristics are accounted for. Although the cutoff or eligibility threshold can be defined non-parametrically, the cutoff has oftentimes or in practice traditionally been defined through an instrument or through a particular specific variable. So discontinuities and delays in program implementation based on eligibility criteria or other exogenous factors can be very useful in an experimental program evaluation generally. So people above and below a cutoff point or a threshold, assuming they are similar in observed characteristics, can be distinguished in terms of outcomes. So people below a certain cutoff or threshold who might have received or will receive the program activities or participate in the program can be compared with a group of people above that cutoff point in terms of the differences in outcomes of the two groups after program intervention. So samples across the cutoff point would have to be sufficiently close to the eligibility cutoff to ensure comparability. So when drawing samples from these two groups, below and above the cutoff point, the samples identified in both groups, above and below, should be close to the cutoff point, not very far from the cutoff point, because it's assumed that those near the threshold, near the cutoff, will certainly have some characteristics that are similar and so allows comparability of the two groups. Unobserved heterogeneity may be a factor if people within the eligible targeting range exhibit or show variation in actual take-up of the program, and that can lead to selection bias. Now, in such cases, eligible and non-eligible samples close to the eligibility cutoff point would be taken to compare the average program. So the idea is if samples are drawn very far from the cutoff point, the samples drawn may have differences in characteristics because they're very far from the threshold or the cutoff point. Now, to avoid that, the samples must be drawn close to the cutoff point to minimize selection bias or to reduce selection bias. Discontinuity approaches, somehow they are similar to instrumental variable methods that we looked at in the previous lesson, in that they introduce an exogenous variable that is highly correlated with participation, but not key or the basis for participation. These are variables that are used as eligibility requirement, but they are not themselves considered for or akin similar to participation or to the program activity or treatment activity. For example, there's this program, the Grameen Bank microcredit program, which targets households with land holdings of less than half an acre. So households or families that have a land size of less than half an acre are eligible to participate. Those with more than half an acre are not eligible. So that becomes a cutoff point. Land holding size that is below or equal to a half an acre becomes a cutoff or threshold. Another example is pension programs that are targeted to populations above a certain age. So individuals below a certain age may not be qualified or eligible to participate in those pension programs. And those above that age, maybe 60 years, maybe 65, then that becomes a threshold. Then those above will receive now the program intervention or activities. Those that are below, because they are not eligible, they will not receive the program intervention. Another example, scholarships are targeted to students with high scores on standardized tests. So high score can be maybe 80%. So those below 80% may not be eligible. Those scoring above 80% would be eligible to receive a scholarship. So the 80% score becomes a cutoff point, a threshold, but it is not itself part of the program activity. Those above then will receive the scholarship, which is a program intervention. By looking at a narrow band of units that are below and above the cutoff point and comparing their outcomes, evaluators can make a judgment about the program's impact or effect. Why is that so? This is the case because it is assumed that households that are just below and above the threshold are likely to be very similar to each other. So reducing the distance in terms of sampling, the distance between the cutoff point and the samples below and above the cutoff point that are sampled or selected is very important, because individuals further away from the cutoff point or the threshold may exhibit other characteristics which are dissimilar to the other group. Regression discontinuity in theory. To model the effect of a particular program on individual outcomes, YI, through the regression discontinuity approach, evaluators need a variable SI that determines program eligibility. So in the examples we saw, the Grameen Bank's microcredit program, the variable SI was land holding size of less than ½ acre. In the student scholarship, the variable SI can be a score of 80% in a particular examination. So that variable determines program eligibility, whether one is eligible or not, and other variables can be age or asset holdings and many other available depending on that particular program. Within that should have an eligibility cutoff, which is denoted by small s star. So the estimating equation, therefore, is yi is equal to beta si plus the error term ai, where individuals with the observation less than the cutoff point or equal to or less than the cutoff point, for example, these will receive the program or they will participate in the program. They are eligible. Whereas individuals whose observation is above the cutoff point or threshold S star, they are not eligible to participate. And individuals in a narrow band above and below, that's very important, narrow band above and below the cutoff point S star need to be comparable in that they would expect to achieve similar outcomes prior to the program intervention. As we'll see in the next slide, figure 4.7.1 gives an example of this property where individuals below a cutoff point or the threshold S star are considered poor, and those individuals above the threshold S star are considered non-poor and so not eligible to participate in the program. So regression discontinuities brings in an element of a threshold, a cutoff point SI. So in this figure, individuals on the left side of the cutoff point S star are considered poor and therefore eligible to participate in the program, whatever intervention it is, the poverty alleviation program with specific interventions in that program. Then those individuals above the cutoff point S star are considered to be non-poor, and therefore they are not eligible to participate in the program. So when it comes to evaluation, it means a sample can be drawn from a narrow band, that is from the poor and the non-poor. Within that narrow band, since we assume that they will exhibit similar characteristics, comparison therefore is possible, and the difference in the outcomes can be attributed to the program intervention. Because in practice, the determination of eligibility may not be sharp or very clear as in a randomized experiment, S can be replaced with probability of participating as probability of participating, which is equal to expected probability of participation T given S variable, observation of S variable, where T is equal to 1 if treatment is received and T is equal to 0 if treatment is not received. In this case, the discontinuity is stochastic or fuzzy, and instead of measuring differences in outcomes above and below the cutoff point S star, the impact estimator would measure the difference around the neighborhood of S star. This result might occur when eligible rules are not strictly adhered to, or when certain geographic areas are targeted, but boundaries are not well defined, and mobility of individuals is common between the two groups, such that the boundaries are maybe not so strictly enforced. So there would be exchanges of information or intervention aspects between the two groups, the intervention and the non-intervention group, or the treatment and the control group. So if the eligibility threshold is exogenously determined by the program and highly correlated with the treatment, one might also use S star as an instrumental variable for participation. Steps in applying the regression discontinuity approach. Standard non-parametric regression can be used to estimate the treatment effect in either the sharp or fuzzy regression discontinuity setup. For a sharp discontinuity design, the treatment effect can be estimated by a simple comparison of the mean of the two groups. There are, however, some advantages as well as disadvantages of the regression discontinuity method. On the advantages, one, it is said that the regression discontinuity approach reduces yields unbiased estimate of treatment effect and the discontinuity. And it can also take advantage of a known rule for assigning the benefits, the benefit that is common in the design of social policy, like the examples we gave earlier for the poverty alleviation program. So we want the people, the ultra poor, people below a certain level of land holding or income, etc. And finally, a group of eligible households or individuals need not be excluded from treatment when it comes to evaluation. We just establish a cutoff point and then compare the two groups below and above and see the differences in the outcomes. However, the concerns with regression discontinuity design include the possibility that eligibility rules will not be adhered to consistently and potential for eligibility rules to change over time. So, as may be the case in a social policy program or interventions, where rules change over time, okay, or not strictly adhered to, loosely adhered to, then regression discontinuity approach may have problems to be used to make unbiased estimates of the outcomes. It also produces local average treatment effects that are not always generalizable to the larger population. And the effect is estimated at the discontinuity, so generally fewer observations exist than in a randomized design. And lastly, program officials may not always know exactly the eligibility criteria. As a result, behavioral responses to the program intervention may be confused or taken as actual targeting rules. These are some of the drawbacks of the regression discontinuity approach. Thank you for your attention.